Now, so far what we have done is calculating the future value, calculating how much will I have in the future, later on, right? If I do this deposit, how much would I have in the end? What we're going to do right now is the present value, okay? So the present value of an annuity is the principal that must be invested today to provide the regular payment. So let's say when you retire in whatever years, right? And let's say 20 years, 30 years, 40 years, whatever your age is, right? So let's say when you retire in 20 years, you want to have some money in the bank that will give you a regular payment of $1,000 every 2 weeks. How much money you should invest right now? We have to, you know your regular payment. Your regular payment is $1,000. And later on, in the future, you want to take out $1,000 every month. How much you should invest right now? So you're looking for your present value. Okay? So the questions, you have to read the questions very carefully to know if you're looking for P, okay? PV, which is the present value. You can see it as P as well, okay? Or if you're looking for your amount, which is A. So the formula is kind of similar, but different, you see? So you have my regular payment, but I have 1 minus, and then 1 plus I to the power of negative N over I. Okay? So PV, R, I, and N, they mean exactly the same thing as in our previous lesson. PV is your present. So let's write this down. So this is the present value. Or the amount needed today. R is the regular payment. It could also mean the regular withdrawal. Right, so how much money you want to take out every month, let's say. A is the interest rate per compounding period, so it's the same idea. Right, it's the same idea where you have to divide it by big N. Right, you divide your rate by big N. And N is the number of compounding periods. As per the previous formula, this can only be used if your regular payment intervals is the same as a compounding period. Okay, so if it's monthly compounding period, then your regular withdrawal have to be monthly. So let's look at an example. Victor wants to withdraw $700 at the end of each month for 8 months, starting 1 month from now. His bank account earns 5.4% per year compounding monthly. How much must Victor deposit in his account today to pay for the withdrawals? Okay? So the question is asking you how much must Victor deposit in his account today? So that is PV. You're looking for PV. Okay? So I don't know what PV is. What is R? 700. How do you know that this is R and not something else? At the end of each month. Right? At the end of each month. So that's telling you that it's a regular thing. It's happening every month. For 8 months, so what does that represent? Do I need to do anything to it? Is N 8 or do I need to do anything with it? It's 8 months, right? It's already in months. And my compounding period is monthly, right? So they have the same unit, so I don't have to do anything with it, right? If it was like compounded weekly for 8 months, then we have to do something. Okay? What's your I?
I have 5%, 5.4%.
0.054.
Divide.
Yeah.
And it's 1.
Nope. 12. You're compounded monthly. Right? Compounded monthly. That means your big N is 12.
Yeah.
Right? Yes, I did not have to multiply the small n by 12 because it's already in months. Okay? So now it's the same thing. So I have to use the formula PV equals R1 minus 1 plus I to the power of negative n. It's very important that you have the right formula. Make sure while when you're putting this in the calculator, you have, can you guys give me what's 0.054?
0.0045.
Now, when you do this, can I have your attention for a second? When you do your I, and let's say if your I gave you a number that is very long and repetitive, okay? It's probably better if you actually put the fraction in I instead of putting the number that's repetitive, okay? Because otherwise your number is gonna be, your money at the end are gonna be, it's gonna be a little off, okay? Now I will take that into consideration. I will not mark it as wrong if you put the right numbers in. But if you want to be exact, you have to put the fraction in, so it gives you the correct answer. Okay? But in this case, it's simple 0.0045. I can put it as this. So what would your answer be for this? So he has to deposit $5,488.28 right now, so he can make a $700 withdrawal every month for the next 8 months. So, Victor needs to deposit now. If he deposited $5,488.28, how much interest did the annuity earn?
We have 700, right?
Yeah. So you're withdrawing 700. How much did you actually withdraw altogether?
700 per 8.
Times 8, yeah?
8 is the final amount.
Yeah.
And then this one was, not the opposite. This one was, this one I didn't find.
That's right. So if you find the 700, if you do the 700 times the 8, so this is how much in total he withdrew,
Yeah.
right? You take away how much he put in, So to find the interest that the annuity have earned, do is you find